Hello students, welcome to the lecture of hydrocarbons. In the last lecture, we had discussed about various types of elimination reactions and we had discussed about the preparation of alkenes from alcohols. Now we will start the preparation of alkenes from alkyl halides. We had started it in the last lecture, but today we will study it in more details. So, like the alcohols, alkyl halides also undergo elimination reaction to give alkenes. So, let us start. Preparation of alkenes from alkyl halides. Okay. So, alkyl halides undergo dehydrohalogenation. Okay. Let us say this is ethyl bromide, right. In presence of alcoholic KOH and heat, it forms ethene. What is alcoholic KOH? Alcoholic KOH means KOH dissolved in alcohol. Okay. So, how does the reaction proceed? So, KOH means it is a base, so it will give K plus and OH minus, right. So, OH minus will take up one electron from the beta carbon. Why beta carbon? This is bromine, okay. So, the carbon that is attached to bromine is the alpha carbon and the adjacent carbon is the beta carbon, or if this is 1 then this is 2. So, it will take up this hydrogen, this bond will break and a double bond will be formed and bromine will be eliminated. So, ethene is formed. This reaction is called 1,2 elimination or beta elimination. We have studied about different kinds of elimination according to the relative positions of the leaving groups. So, 1,2 elimination or beta elimination is this. This process is also called dehydrohalogenation. Dehydrohalogenation, because as a whole HBr is liberated here, right, this hydrogen and this bromine. So, this is called dehydrohalogenation. Now, when we had studied about the preparation of alkenes from alcohols, it was like this. So, in this case, we added concentrated H2SO4 and concentrated H2SO4 was there and lone pairs of oxygen had taken up this H plus and OH2 plus was formed. So, this is a good leaving group. This leaves as water molecule and a positive charge was formed on this carbon. So, a carbocation was formed. After that, HSO4 minus had taken up this hydrogen and the double bond was formed. So, this was E1 mechanism. This was the rate determining step, the formation of the carbocation. So, this is the E1 mechanism. But in case of alkyl halides, we have seen that the elimination of hydrogen and bromine both takes place in the same step. So, this is a concerted reaction or single step reaction. We had studied earlier that E2 mechanism has concerted pathway. So, this is E2. So, this was the preparation of alkenes from alkyl halides. Now, this also follows the SATHEE rule. So, let us see some examples. In this case, this is quite simple because there is one hydrogen and there is chlorine. So, HCl will be liberated and this is the alkene formed. Now, if we say for this compound, so here two possibilities are there. One can be this and another can be this. So, we had studied in the last class that according to the SATHEE rule, the more substituted alkene is formed, that is the product where the double bonded carbons has maximum number of alkyl groups bonded to them. So, in this case, in the double bonded carbons we see only one alkyl group and 3 hydrogens, but in this case there are 2 hydrogens and 2 alkyl groups. So, this product is more substituted. So, this is the major product according to the SATHEE rule. Let us see one more example. So, if this is an alkyl halide, a cyclic alkyl halide, and we have given sodium hydroxide and ethanol. Now, sodium hydroxide is also base like potassium hydroxide, and ethanol, this is the solvent. So, as a whole this means alcoholic sodium hydroxide. So, alcoholic sodium hydroxide can also be used for this reaction. So, in this case also there are two possibilities. One is this and another possibility is this, but since we will take the more substituted alkene, so this will be the major product because this has 3 alkyl groups, that is 3 substitutions. These are not alkyl groups exactly, they are connected to the ring, but there are 3 substitutions and 1 hydrogen, but in this case there are 2 hydrogens and 2 substitutions. So, this one is the major product. Okay. Now, the reactivity order. So, among the alkyl halides, tertiary alkyl halide will be the most reactive, then secondary alkyl halide and then primary alkyl halide. This is the order of reactivity of alkyl halides. And among the halogen groups, I minus will have greater reactivity, that is the iodides, then bromide, and then chloride. Okay, because iodide is the best leaving group. I minus is the best leaving group. So this is the reactivity order of the halides. Now the next method for the preparation of alkyl halides is from vicinal dihalides. Okay. What is vicinal dihalides? So, if this is an alkane and two halide groups are there in 1,2 position, that is in two adjacent carbons, this is called vicinal. And if two halogen atoms are attached to the same carbon, then it is called geminal. Okay. So this is geminal, this is vicinal. From vicinal dihalides, we can form alkenes. So this is one vicinal dihalide. In presence of zinc metal and heat, this forms, and alcohol as solvent, alkenes are formed. Okay. This method is called dehalogenation. Why dehalogenation? Because two halide ions are being liberated, that is, we can consider that X2 is being liberated. Okay. And as a side product, we get a zinc salt with these halides. So this is called dehalogenation. Now we will see its mechanism. Okay. So this is 1,2-dibromoethane plus zinc. It is heated and ethanol is used as a solvent. So at first we know that zinc, if zinc, this is the metallic zinc, it is in zero oxidation state, and zinc has zinc 2 plus as a stable oxidation state. So zinc will become zinc 2 plus and form bond like this. So one bond is with this alkyl group and one bond is with bromine. Okay. Now in the next step, this bond breaks, double bond forms and bromide is liberated. So we get zinc bromide, that is ZnBr2, and one alkene is formed. This is ethene from 1,2-dibromoethane. Okay. So this is the method for conversion of vicinal dihalides to alkenes. In the next method, we obtain alkenes from geminal dihalide. Okay. So we had said what is geminal. Geminal means connected to the same carbon. So, geminal dihalide means okay, let's say like this, and we need 2 molecules of this compound. We can write like this. Okay, 2 molecules of this geminal dihalide and 2 molecules or 2 atoms of zinc. So, when we have 2 equivalents of these, remember the Woods reaction. What had happened in the Woods reaction in the preparation of alkanes? We had taken 2 Na, right? And 2 NaCl was liberated, and these 2 alkyl groups joined and formed a higher alkane, right? This was the Woods reaction. So, in this case also quite similar thing occurs here. Since there are 2 bonds and 2 chlorides, so 2 zinc chloride will be liberated, and since 2 bonds are breaking, that is each carbon is losing 2 bonds, so 2 bonds will form in between. So, we get a higher alkene. So, this is the method for preparation of alkenes from geminal dihalides. So, we have discussed all methods for the preparation of alkenes. So, now we will see the physical properties of alkenes. Okay. So, the first property is that alkenes are more polar than alkanes. Okay. So, alkenes have quite similar physical properties to alkanes except polarity and isomerism. We have already studied isomerism. So, polarity is mostly due to the pi electrons, loosely bound pi electrons. Okay. So, the second property is the first 3 members, that is C2 to C4, that is ethene to butene, are gases. C5 to C17 are liquids, and greater than C17, that is C18 onwards, they are solids. So, we can also write this as greater than or equal to C18, they are solids. And about the boiling point, boiling point of alkenes increases with increase in size of alkenes. Okay. So, roughly for every CH2 group added, boiling point increases by approximately 20 to 30 Kelvin. And similar to alkane, straight chain alkenes have higher boiling point than isomeric branched chain alkenes. We have discussed the reason behind this while we were studying about the alkanes. So, these are the physical properties of alkenes and the preparation methods of alkenes. In the next lecture, we will study about its reactions. Thank you.